Good afternoon. We are going to be doing the notes for 5.4. This section deals with inequalities in one triangle, which basically relates the biggest side with the biggest angle, the smallest side with the smallest angle. So we're going to start out today with a theorem. It doesn't have a title, and this theorem says if one side of a triangle is longer than a second side, then the angle opposite the first side is larger than the angle opposite the second side. Let's say that one again. If one side of a triangle is longer than a second side, then the angle opposite the first side is larger than the angle opposite the second side. Okay, we're going to label this triangle A, B, C. And using this theorem, if the measure of side AC is greater than the measure of side AB, then this is where we get to the opposite angles. Okay, so if AC, this one's AC, is bigger than side AB, then the angle opposite AC, which is B, so angle B is going to be greater, or sorry, put the M in for measure. The measure of angle B is going to be greater than the measure of angle C, which is the angle opposite the smaller side. All right, that's theorem 5.9. Here's theorem 5.10. This theorem says, and this one is the opposite, it goes from angles. So if one angle of a triangle is larger than a second angle, then the side opposite the first angle is longer than the side opposite the second angle. Okay, so again, let's label our triangle A, B, C. So this theorem goes from angles to sides. So the hypothesis, if the measure of angle A is greater than the measure of angle C. Okay, so here's angle A, and here's angle C. Then we can say that the side opposite A, which is BC, is going to be longer than the side opposite C, which is AB. So the length of BC, and that's why there's no bar, because it's the length of BC, is greater than the length of AB. So theorem 5.9 goes from sides to angles. 5.10 goes from angles to sides. All right, let's practice using these. So example 1, name the largest angle and the smallest angle of the triangle. Okay, so the largest angle is going to be opposite the longest side. 10 is the longest side, so I is going to be the largest angle. So the largest is angle I. Now the smallest angle will be opposite the smallest side. The smallest side is 6, so the smallest angle is going to be J. So the smallest is angle J. Pretty simple. Okay, example 2. Name the longest side and the shortest side of the triangle. So the problem here is that we don't have all three angles. So we're going to need to use triangle sum theorem to get angle T, and then we can figure out which sides are shortest and longest. Okay, so triangle sum theorem says all three angles add up to 180. So 46 plus 105 plus T has to be 180 degrees. Put a box around it. Okay, 46 plus 105 is 151, plus t is 180. Solving for t, we're going to subtract 151 over to the right, and we get t equals 29 degrees. All right, so let's put that on our drawing, 29 degrees. Okay, like the one before it, the longest side will be opposite the largest angle. The largest angle is definitely S with 105, so the longest side is RT. So longest is side RT. Okay, now we're going to do the smallest. The smallest side is opposite the smallest angle. 29 is definitely the smallest angle, so the side opposite T is RS. So the smallest side is side RS. All right, flip the page. All right, this is a really important theorem that you're going to see a lot. It's on the test, it's on the final. It's called the triangle inequality theorem. And basically, it's side lengths needed to form a triangle. So here we go, Theorem 511, the triangle inequality theorem. This says, if a figure is a triangle, then the sum of the lengths of any two sides is greater than the length of the third side. So let's put a couple little drawings here out on the side. I want you to draw 3 lines, small lines, like 3 centimeters in length. 1, 2, 3. If you don't have your ruler, pause the video, grab your ruler. Okay, so there are 3 possible scenarios if you're given the sides of a triangle. If 2 of the sides are so small that when you add them together, they're not even as long as the third side, you're going to get no triangle. You can see that those sides don't touch. They can't make a triangle. Well, what if those sides are a bit longer and they're able to add up exactly to the length of the triangle? Well, as you can see, the sides will fall flat because they're exactly the same length as the triangle. So in that case, if they are equal to the longest side, there is still no triangle. So if the 2 together are less than the longest side, no triangle. If the 2 together are equal to the longest side, also no triangle. The only situation we have that will get a triangle is if the sum of the angles is greater than the third side. Because what will happen, as you see here, is they can actually meet up at a point outside the third line and make a triangle. So that situation will make a triangle. So the sum of the lengths of any 2 sides has to be greater than the length of the third side. So in summary, side 1 plus side 2 has to be greater than side 3 to make a triangle. So using this triangle, AB plus BC, those 2 added together have to be greater than the third side, which is AC. BC plus CA have to be greater than the third side, which is AB. And CA plus AB has to be greater than the third side, which is CB. All right, let's do some practice problems with this. Okay, example 1. Given triangle ABC is a right triangle with the measure of angle C 90 degrees. Let's mark that. So 90 degrees. Complete with less than, equal to, or greater than. So angle C blank angle A. Well, remember that the 3 angles have to add up to 180. So if this one's 90, it means that when you take the sum of the other two, they also have to be 90. So both of them individually must be less than 90. So angle C should always be greater than any other angle. Okay, B, angle C blank, A plus B. Well, if C is 90, A and B must also be 90. So they are equal. And the third one, side AC blank side AB. Well, AB is the hypotenuse, which is opposite the 90. And the hypotenuse is always the longest side. So AB will be greater than any other side in the triangle. Okay, example 2. This is one of our more challenging questions. You'll need to practice it a couple times to get the hang of it. It says the lengths of two sides of a triangle are 8 and 13. Then the length of the third side must be greater than blank, but less than blank. Okay, so we're going to call the third side x. So the length of x, the x side. So here what we're going to do, just like here where we wrote out the sum of two sides has to be greater than the third, we're going to do the same here. We're going to do all three of them. So x plus 8, that sum has to be greater than 13, the third side. X plus 13 has to be greater than 8, so two sides have to be greater than the third side. And the last one, 8 plus 13 has to be greater than x. So we've listed the sum of two sides, and there's only 3 ways that could go. And then we solve. So if I subtract 8, I get x greater than 5. If I subtract 13, I get x greater than, negative 5. You can't have a negative side length, so this one doesn't produce an answer for us. The third one, 8 plus 13 is 21, greater than x. Flip it around, x is less than 21. So when you follow this process, one of the inequalities will give you a minimum, what x is greater than. So x has to be greater than 5. And one of them will be a no solution. It won't give you information. The third one, x is less than 21, must be the maximum. So less than 21. You can show your answer this way as a compound inequality, or you can say x greater than 5 and x less than 21. These are the ranges of x values that will actually make a triangle. So if x is 6, a triangle is possible. If x is 10, a triangle is possible. Only when you get past 21, like if x is 25, then a triangle won't be possible. It goes the other way as well. Anything lower than 5 and a triangle isn't possible. So x equals 4, a triangle isn't possible. It's only within this range that a triangle will actually be able to happen. Otherwise, one side will be too big for the other two. Okay, so here's our third question. Is it possible for a triangle to have sides with the lengths as indicated? Now I'm going to show you a little shortcut. You could do all 3 pieces and that will work just fine. But you can take a bit of a shortcut because really the major thing is, will the sum of the smallest 2, will that be greater than the third? That's really the only one that matters. So you only need to pay attention to the smallest 2 sides. So we're going to take 6 and 8. 6 plus 8 equals 14. That is greater than 10. So yes, a triangle is possible. Let's do the next one. Take the smallest 2 sides. 3 plus 4 is 7. 7 is less than 8. So no. You can't make a triangle. It has to be greater than the third side. The last one, you'll notice the smallest 2 are out of order. Still use the smallest 2. 4 plus 2 equals 6. 6 is equal to 6. Those two sides are going to fall flat against the third side. So no, a triangle is not possible. All right, that's the end of the notes today. I hope they were helpful. You might want to have this page out while you're working on your homework because many of the problems look just like these. Have a good afternoon.